In this video, I'll show you how to model direct variation equations. This is part 5 in the series. First question asks, two similar solids are shown below. Find the hole diameter. So we need to find the diameter of this hole, and the way we can do that is compare similar sides. So I can compare 8.01 to 13.4. So 8.01 to 13.4. Similarly, I can compare 22.5 to this diameter, d. Now this is a simple matter of cross multiplication. We multiply 13.4 times 22.5. 13.4 times 22.5 gives us 301.5, and d times 8.01 is 8.01d. Dividing both sides by 8.01 gives us 301.5 divided by 8.01. We end up with a diameter of 37.64. So d is equal to 37.64 centimeters. In question 2, we're asked, the triangular top surface of the smaller solid shown in the figure has an area of 31.2 centimeters squared. Find the area A of the corresponding surface on the larger solid. To answer this question, we'll need to understand the following. Areas of similar plane or solid figures are proportional to the square of any two corresponding dimensions. What we will do is compare this area, 31.2, to this area, which we'll call A, and I will compare 8.01 of this figure, and it needs to be squared with 13.4 of this figure. Let's go ahead and find out what A is. A times 8.01 squared is 8.01 squared A, and 13.4 squared times 31.2 is 31.2 times 13.4 squared. We get 5,602. 5,602. Dividing now both sides by 8.01 squared, divided by 8.01 squared gives us the area of that top triangle, which is 87.31. A is equal to 87.31 centimeters squared. Lastly, we're asked, if the volume of the smaller solid in the figure is 255 centimeters cubed, find the volume V of the larger solid. To do this type of question, we need to understand the following, where volumes of similar solid figures are proportional to the cubes of any corresponding dimensions. Once again, I'll compare this volume to that. 255 over V is equal to 8.01 over 13.4, and both of these will be cubed. Doing the same math as before, 13.4 to the power of 3 times 255 gives us this pretty large number. Keeping that in our calculator, don't erase it. V times 8.01 to the power of 3 is 8.01 to the power of 3V. What we would do next is divide both sides by 8.01 to the power of 3. So this number divided by 8.01 to the power of 3 gives us 1,193. 1,193 is equal to our V, and this would have units of centimeters cubed. And so there you have it. 3 examples on how to model direct variation equations.